In this screencast, we'll take a look at the excess air. Since air is free, it is typically beneficial to feed it in excess so that we can achieve the highest possible conversion of other reactants which are not free. Let's take a look at the reaction of iron plus oxygen to produce rust. We balance this equation with 3 oxygens and 2 rust molecules. So let's assume for this problem that we want to create rust. So we have a ruster that will react our iron to make rust. Coming in, we have 8 moles per hour of iron. Coming out, we have rust. And to make the rust, we have to have a stream coming in of 40 moles per hour of air. The main equation that we're going to need is the equation for percent excess air. This is defined as the moles of air fed to the system minus the moles of air theoretical divided by the moles of air theoretical times 100%. In order to solve this system, we need to determine what the moles of theoretical air are coming into the system. So let's start out by first finding the theoretical oxygen. Theoretical oxygen is the amount of oxygen required for complete combustion of reactant. In this case, our reactant is 8 moles per hour of iron. And we know from balancing our equation that 3 moles of O2 are required to burn every 4 moles of iron. This equation tells us that this system will require 6 moles per hour of oxygen to completely combust the iron. Since our air stream contains more than just oxygen, we have to account for the fact that it does contain other things, namely nitrogen. So for every 6 moles per hour of oxygen, we know that we have 79 moles of N2 for every 21 moles of O2 in air. So this tells us that we have 22.6 moles per hour of N2 coming into the system. So our total theoretical air equals our oxygen plus our nitrogen, which equals 28.6 moles per hour of air. Finally, let's calculate our percent excess air. We have 40 moles per hour of air coming in minus our theoretical 28.6 moles per hour divided by 28.6 moles per hour of theoretical air and times 100%. And this leaves us with a percent excess air of 40%. Now, the key point that I want to emphasize with excess air is that it's independent of how much rust we actually produce. Take a look at our ruster system. We didn't actually specify how much rust we're producing. We specified how much iron is coming in and how much air is coming in, but it doesn't matter how much actually reacts. All percent excess air depends on is the theoretical complete combustion of iron. Assuming that we only had half of the iron combust, and we still have 40% excess air entering the system. Key thing to remember here is just that percent excess air is dependent only on the theoretical complete combustion of the reactant.